Okay, this is going to be an informational tutorial video on how to graph absolute values. So let's get started. The first thing you want to always identify is what the parent function is. So in this case, I identified the parent function as being y equals the absolute value of x. And we always want to graph the original points for the parent function. So in this case, the original points for the parent function for absolute values, we always want to start with -2, -1, 0, 1, and 2. Those are usually always our starting points. And to get the y values, we always take the what? The absolute value of the x values. So the absolute value of -2 is 2. The absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. And the absolute value of 2 is 2. Okay. After that, we want to think about how this 2 affects everything. So to figure that out, let's make another XY chart, okay? And if we do another XY chart, we just have to double all the Y values, okay? So if I double all the Y values here, that's what this 2 does in front. Doubling all the Y values, I'm going to get 4 because double 2 just gives me the 4 right here. Then you'd have 2, 0, 2, and 4, okay? So those are all double the Y values. Then the last step is we have to subtract 2 from the Y values because there's a -2 at the end. So to subtract 2, I'm going to do one last XY chart. Subtracting 2 or going down 2 just means that the Y's are all going to be 2 less, okay? It means that all the X values are going to stay the same. And if all the Y values are 2 less, then I'm just going to have a -4. No, 2 less would be 2, 0, -2, 0, and 2. So those are all 2 less than the previous XY chart. So now if we graph all those points, I would have -2, 2, okay, -1, 0, 0, -2, 1, 0, and 2, 2. And that would be the final graph. We can just connect the points. And if you notice, that's just a V move down 2, and all the heights got doubled. That's pretty much what happened. So let's just write down the summary again of what I just did. I noticed that the original function is an absolute value function. So what that means is we want to write down the equation y equals absolute value of x is the original parent graph function. After that, we want to write down the original points for the parent function graph. And then each one of the numbers in the original function changes something in the original XY chart. The 2 in the front of the absolute value of x right here doubles all the Y values. So I literally just doubled all the Y values right here. And then after that, the -2 at the end subtracts 2 from all the Y values. And then if I just plot all those points, I clearly see that I have a V move down 2, okay? Let's do the second one, okay, just as a review. So again, this is another absolute value. So for this one, we can just say, okay, let's always start the same way, -2, -1, 0, 1, 2. If you notice, it's the exact same starting spot or same XY chart as the one before. You always start with the same points, okay? So I'm going to recopy the Y values. So whenever we have an absolute value, these are some good starting points, okay? And then what actually happened here? Let's do the new XY chart, okay? So for the new XY chart here, what's going to happen? The x plus 1 on the inside, we have to move the whole graph to the left. That's what that means. So that means that we're going to subtract 1 from all the x values. So let's do that right now. If I subtract 1 from all the x values, I get -3, -2, -1, 0, and 1. And then what does the 2 do? It doubles all the Y values. So I'm going to double all the Y values. Okay. Okay, so 4, 2, 0, 2, 4 is all the Y values that got doubled. And then at this point, I can just plot the points. That's all I need to do now. So if I plot the points now, negative 3, 4, okay, negative 2, 2, negative 1, 0, 0, 2, and then 1, 4. Now I have 5 good points, so you can just connect the dots. And this problem makes sense here. Why does the problem make sense? I can clearly see that the V got moved left 1 unit, and all the heights look like it made the graph like tall and skinny, so it looks like the plots are plotted correctly, or the points were plotted correctly. Okay, let's go down some more. Let's do one that got flipped. So I'm going to do one of these, okay? How about number 3? That's a good one, number 3. So again, we always start the same way. You don't have to rewrite the XY chart every time because it's the same thing for any absolute value equation, but I'm just going to do it one more time. So if we do it again, absolute values, right? What do? We usually always want to start with negative 2, negative 1, 0, 1, and 2, okay? And how do we get the y values again? Remember, it's always the same thing. We always start with the same XY chart. It's always the absolute value of the x values, okay? All right, so all the y values are on the right. And then we need to think about, okay, what do the numbers on the transform function mean, okay? The minus 2 adds 2 to all the x values, and the negative 3 multiplies all the y values by negative 3. So if I write down the new XY chart for that portion, okay, subtract, now let's think about this again. So x minus 2. X minus 2 is going to do what? That moves the graph to the right 2. So if I move the graph to the right 2, then I'm going to be adding 2 to all the x's. 0, 1, 2, 3, 4. I added 2 to all the x's, okay? And then what? Negative 3 multiplies all the y values by negative 3. So I'm going to get negative 6, negative 3, 0, negative 3, negative 6. Then I can just plot the points, okay? 0, negative 6 is down here. 1, negative 3, okay? 2, 0, okay? 3, negative 3. And then finally 4, negative 6. So those are 5 good points. Makes sense because it looks like this is an absolute value equation that moved to the right 2 and that also got flipped, okay? All right. Then I'm going to do one more absolute value one, and then I'll jump down to a quadratic, okay? So let's jump down to number 8. That's one that's probably the hardest one on this paper here. So for number 8, again, this is another absolute value equation. So I need to write down another XY chart. Again, it's always the same XY chart for absolute values. We start with negative 2, negative 1, 0, 1, and 2. Okay. And then we always take the absolute value, right? Because the parent function is y equals the absolute value of x, all right? So the absolute value of the x's are going to be 2, 1, 0, 1, and 2, okay? Then we have to think about what do the numbers in the equation do to that xy chart, okay? So the plus 2 moves the whole graph to the left 2, and the negative 3 multiplies all the y values by negative 3. So I'm going to write that down right now. Okay. So left 2, all the x's get subtracted by 2. So I'm going to have negative 4, negative 3, negative 2, negative 1, and 0. Okay. Negative 4, negative 3, negative 2, negative 1, and 0. That's subtracting 2 from all the x's. And then I'm going to multiply all the y's by negative 3. So I'm going to have negative 6, negative 2, 0, negative 2, whoops. So I have to do negative 3 for all of them, right? Negative 3. So negative 6, negative 3, 0, -3, and -6, okay? And then the last step is to add 3 to all the y values, okay? So what's the process when you're changing the points? We always want to figure out what's happening left and right first. And so we always focus on the inside. Then we focus on what's multiplied on the outside. And then very lastly, we focus on what's going up and down, okay? So finally, for the last set of points, I'm going to keep all the x values the same because we're trying to move everything up 3 now, right? So I'm going to keep the x's the same. And then all the y's are going to be added by 3, okay? So if I add 3 to all the y's, I'm going to get -3, 0, 3, 0, and then another -3, okay? So if I plot those points now, I'm expecting what? I'm expecting a v that's moved which way? It's x plus 2, so that's going to go to the left. So I'm expecting a v that's moved left 2 and up 3, somewhere in the upper left, move left 2 and up 3, but I'm expecting a v that goes down because there's a negative number in the front. So let's plot the last set of points and see what happened. -4, -3. Okay, so that's going to be right here. -3, 0. Okay. -2, 3. Okay. -1, 0. And then finally 0, -3. So that looks exactly what I was expecting. It's literally a v that got moved left 2 and up 3. And it's flipped upside down. Okay. Okay, so from those few examples, from how many examples did I do? I did 1, 2, 3, 4. So from those 4 absolute value examples, you should be able to do all the rest, okay? So you should be able to do 4, 5, 6, all the rest you should be able to do, okay? Now let's look at some absolute value equations. So for number, let's say number 9, let's say, right? Number 9, again, instead of starting with the same XY chart, because we did this XY chart for absolute values, now we're going to change the XY chart a little bit. It doesn't look the same because it's an absolute value. We're not going to start at the same spot. So for number 9, we're still going to start at -2, -1, 0, 1, and 2. But for the parent function, which is y equals x squared, we're going to square all the x's, okay? So if I square all the x's, I'm going to get 4, 1, 0, 1, 4, okay? And then what do? So we always want to move left or right first, and then take care of the outside, okay? So the -4 moves everything to the right 4, so I'm going to add 4 to all the x's, okay? So if I add 4 to all the x's, I'm going to get 2, 3, 4, 5, 7. 2, 3, 4, 5, 7. Okay. Or 2, 3, 4, 5, 6. 6. Okay. And then the minus sign in front multiplies all the y values by -1. Okay, so that would be -4, -1, 0, -1, -4. Okay, and then there's one last thing that happened. The last thing that happened is that all the y values got subtracted by 1. So I'm going to write down the last set of points. Okay. So all the x's stayed the same. The only thing that changed are the y values. Okay. So I still have the 2, 3, 4, 5, 6. Subtracting all the y values by 1, I get -5, -2, -1, -2, -5. And then at this point, I just want to plot. And I would always suggest circling the point where it looks like everything mirrors. So you see this spot right here. that 4 comma -1 is going to be where everything is centered because everything is symmetrical about that point, okay? So where's 4, -1? 4, -1 is right there. Before you plot anything, you should be expecting a parabola that got flipped down because there's a negative on the outside of the parabola, okay? So I'm going to plot the rest of the points. 4, -1, 3, -2, okay? 2, -5, okay? 5, -2, and then lastly 6, -5. So those are 5 good points. It's a parabola flipped on its flipped upside down, and there's the graph. So this is the thing. You guys should notice that it's very hard if we were to plot the points in the beginning for this one, because plotting these points here, the parent graph points, that's difficult due to the graph being off center. So I feel like changing these points through this XY method can be helpful if the original points were hard to move, okay? All right, I'm going to do a couple more parabola ones. Actually, let's just do a different one. So let's do a square root. A square root example would be good. Let's do, crap. So I'm going to do number 24. That's probably the hardest one on this sheet, okay? So 24, okay. Again, so we're going to start with a different XY chart now because it's a square root. So square roots are different from absolute values. They're different from quadratics. How is it different? The parent function is y equals the square root of x, okay? So we start with a different set of points. Square roots can't take negative numbers, so we're going to choose values that are nice for square roots. 0 is nice because the square root of 0 is 0. 1 is nice because the square root of 1 is 1. 4 is nice because the square root of 4 is 2. And 9 is nice because the square root of 9 is 3, okay? Now, you always want to go left and right first, then after that, take care of the number on the outside. So let's write down the new set of points right here on the left. So if I do the new set of points here, I'm still, if I move everything, the x minus 3 means I move everything right 3. So if I move everything right 3, I'm going to be adding 3 to all the x's. So 3, 3, 4, okay, 7, and then finally 12, okay? And then what does the 2 do? The 2 multiplies all the y values by 2. So 0, 2, 4, 6, okay? Then lastly, the minus 5 right here subtracts 5 from all the y's. So now we want to get the final set of points, okay? So the final set of points, I'll write down right here. If I'm only moving down 5, only the y's get affected, okay? So I still have 3, 4, 7, 12. But then all the y's are going to get moved down by 5. And then we just want to plot the rest of the points. All right, so then here we can clearly see that the graph is centered at 3, -5, and then it moves in that direction. Okay. We're not going to be doing cubic functions today. So, all right, so that was the end of the video. I hope this helped. And hopefully you guys will be doing good on your test on Friday. Thanks.